When we differentiate the natural log of x over x to the 7th, I need to use a quotient rule. And I usually say for the quotient rule, if you have a numerator divided by a denominator, then the quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So if I follow this, the denominator would be x to the 7th. And I would need to take the derivative of the numerator, and the derivative of the natural log of x is 1 over x. You then subtract the numerator, which is x to the 7th. The numerator is the natural log of x. And you multiply by the derivative of the denominator, which is 7 x's to the 6th. So because I made that mistake earlier, let me point out some things that I've done. Denominator, x to the 7th, came from right here. Derivative of the numerator, I took the derivative of the natural log of x. The derivative of the natural log of x is 1 over x. Numerator, copied and pasted, so numerator was natural log of x, that's why I copied and pasted it. Derivative of the denominator is the denominator is x to the 7th, so its derivative is 7x's to the 6th. I now need to divide by the denominator squared. Let's clean this up. When I say x to the 7th times 1 over x, that is like saying x to the 7th divided by x, which is x to the 6th. Right here, you don't have to rewrite it. I think that looks prettier as 7x's to the 6th natural logs of x. But you don't have to do that. When you have x to the 7th squared, when you have a power to a power, you are able to multiply those powers together, so that is x to the 14th. In the numerator, I see that there's a GCF of x to the 6th. When I factor that out, I'd be left with 1 minus 7 natural logs of x. And by factoring out that GCF of x to the 6th, I'm able to then see that I can cancel that x to the 6th, and it'll leave me with x to the 8th in the denominator. And my answer would be 1 minus 7 natural logs of x over x to the 8th.